Hi! In this video, we're going to see how integrals of the 1 over x type apply to some word problems. This one's going to be a little bit different than your usual marginal revenue, total revenue kind of question, but it's nice to switch it up every now and then. And remember that derivatives are an overall statement about the rate of change of any function. Okay, so this function is meant to answer the question, how long does it take to learn new vocabulary words? You know, let's say that you're studying a foreign language or something, and you have this long list of new vocabulary to learn. How long does it take you to learn a certain amount of those? So we're going to start by defining a function, v of t, which is the number of new words that you've learned after studying for t hours. So the input variable is t, and it's in units of hours. And the output variable is v, and it's in the number of new words. Alright? I want to make sure I understand the units on the input and the output, because that will help me interpret the derivative. So if I actually take the derivative, which you can either write as v prime or dv dt, that interprets as the learning rate. That's the rate, a per hour rate, at which you will learn the new vocabulary. And remember, dv dt, the derivative, always has units of the output variable divided by the input variable. So the units on this will be number of words per hour, and that really helps me to make sense of it, because if you tell me that I'm going to be able to learn 10 words per hour, that's something that I can understand, right? Okay, so let's pretend that we have the derivative and we're asked to find the total quantity. This is a typical question when you get to the part of the course called integral calculus. Alright, so we have the derivative, and in that case the derivative is 50 divided by t plus 6. Notice how this is of the 1 over x form. It's not necessarily exactly the function 1 over t, but the theme is that it's a number, just a constant value, divided by a linear function of the independent variable. So any linear function mt plus b would be okay to do this type of method on. Okay, so I'm given this derivative. The question is, what is v of t? What is the actual function which tells me the number of new words that I've learned after t hours if I'm actually given the learning rate? So think about this from an experiment type of idea. Maybe the psychologist can only measure the rate at which the student is learning, and then they need to integrate it in order to get the total function. Alright, oh, I already said the answer. How are we going to find v of t? Integrate it, right? We're given the derivative, so we have to use integration to undo the derivative. So we're going to integrate that dt, and that's going to get us started, but of course we're going to end up with a plus c. Inside an application problem, it's usually not cool to just say plus c, whatever, plus or minus, whatever. So then we're going to have to talk about how to figure out what is the unique function that actually answers this question, what is v of t? Alright, well, to get us started with the integration, I'm not really cool with that 50 being up there. It's going to mess up my thoughts. So I'm just going to take the 50 and put the 50 out in front. Okay, now you can kind of see even more so that it's like a 1 over t type of form. But it's not exactly 1 over t, so I can't exactly use the log rule yet. What should I do? Use substitution, right. If it's not exactly what you need, you want to let u be equal to something appropriate, just like this. And in this case, simply saying that u is equal to t plus 6 leads to du is equal to dt. That's good. And then you're going to rewrite that in terms of your u, so that's 1 over u du. And now you can use the log rule, because the integral of 1 over u is log of the absolute value of u. So that's log of the absolute value, but then I'm just going to skip a step because I know what u was. U was t plus 6, and then there's the plus c. Okay, so I'm about halfway done with this problem right now. Keep in mind, it's not very satisfying to report that the number of words I can learn after t hours is equal to this plus c, where c can be any number I want. That's not that good. So in order to solve for the c, that's what we call an initial value problem, or IVP, we need one single point on the total function. Okay? Now it doesn't have to be the point when t equals 0. If we have any other information, we could use that as well. But oftentimes it's easiest to get that information at the point when the independent variable equals 0. Like for example here, if this is a number of new words that I can learn after T hours, it probably makes sense to say the number of new words that I can learn after 0 hours. If I don't do anything, how many new words do you think I'll learn? None. Exactly. It's kind of like the total revenue. If you don't sell anything, you're not going to make anything. If you don't spend any time studying, you're not going to learn any new words. And that's the initial value that's going to allow us to solve the initial value problem. Okay? So V of 0 is equal to 0, but V of 0 is equal to all this. So that tells me that 50 times the log of 0 plus 6, which is 6, plus C is equal to 0. And that actually tells me that C is equal to negative 50 log 6. I'll let you take a look at that for a minute. Okay, this line right here I got by plugging T equals 0 into that equation. The plus C is still there. The whole thing has to be equal to 0, and so in the usual manner, in order for me to solve for C, I just take all the stuff that's not C and I move it to the other side. And so that's why I have C is equal to minus 50 times the log of 6. Do you like that number? Maybe you're not used to seeing numbers in that kind of weird form. This is like reporting the number, square root of pi or something, or e to the 2. This is what we call the exact form. If you ask your calculator what this number is, you will get a decimal approximation. But this is the exact form of what the plus C is right there. And so when I try to answer the question, how many new words can I learn in 2 hours, I'm going to actually use the exact value of C, and that way I can avoid any round-off error. Then in the end, I'll probably round this to the nearest word. It kind of makes sense when I ask how many new words, and it kind of makes sense that I would round this to the nearest whole number because I'm not going to learn half a word. Round it to the nearest whole word. Okay. Now let's write down what V of t equals after we solved it out. V of t is equal to 50 times the natural log of the absolute value of t plus 6. And then where I had a plus c, I'm actually going to write minus 50 log 6. Remember, this isn't really a functional part. This is the additive constant plus c. It just has a function log in it, but it's not log of x, it's log of 6. So this is actually a number in an exact form. So there you go. Now when it says how many can I learn in 2 hours, I just need to plug in t is equal to 2. Make sure that your units are always correct as usual. If it said how many words can I learn in 30 minutes, that would be t equals 0.5. Okay? So this one is in hours and t is in hours. So I'm going to plug in t equals 2. So that's 50 log of, well, the absolute value of 2 plus 6 is 8. So the absolute value of 8 is 8. So 50 log 8 minus 50 log 6 equals, now you're going to want to get the number from your calculator. And if you like, you can punch in 50 log 8 minus 50 log 6 and get the number from your calculator. Or if you like a little more practice with logs for review, how could I combine this? 50 log of what? I could actually combine these two things using log rules. Do you remember what it is? The 50 is common to them both, so I brought the 50 out. Log 8 minus log 6 is log 8 over 6. That's right. So then simplifying that, this is actually 50 times the log of 4 over 3. Okay? So you could either punch in this much stuff into your calculator, or if you use a little cleverness with the log rules, you can just punch in that into your calculator. And either way, you're going to be looking for the number approximately 14.384 ... rounded to the nearest whole word. So all in all, the answer is 14 new words. Okay? 14 new words is how many words I can learn in 2 hours. It's probably a pretty hard foreign language.